Hi, I'm Herbert Wolverson with Arden Labs. I'm going to be talking to you today about Rust Web Services with Axum and SQLx. We're going to be building a CRUD service. Before we get started, it was really nice to meet a whole bunch of you at GopherCon and RustConf. It was great to see there's some excitement going, and this presentation is built partly on what I learned there with what sort of things you guys are interested in, and partly based on the Rust Foundations course we'll be talking about later. All right, let's go ahead and dive into the content. Okay, like I said, this is Rust Web Services Deep Dive, CRUD, which is create, read, update, delete, the operations that you always find yourself performing with databases and APIs that access those databases. We're going to be using a couple of crates called SQLx and Axum. The source code for this presentation is at the GitHub link there. It should also be in the YouTube comments. Hi, Alejandro. All of the source code for this is packaged up to with the view to making it useful to you to use as a template, get you up and running quickly, get you some useful content. I am Herbert Wolverson. Like I said, I'm the Arden Labs Rust guy. I do training. We offer some consulting. I'm also the author of Hands-on Rust and Rust Brain Teasers through the Pragmatic Programmers. Before that, I wrote the Rust roguelike tutorial, a big learn Rust by making a game type of thing. I also contribute to a whole lot of open source projects, including LibreQOS and BracketLib. BracketLib is mostly intended for use with hands-on Rust, but it's a fun, easy way to throw games together. All right, so today we're going to build a full stack, and we're going to try and do it within the time frame of a 1-hour presentation, including questions, the giveaway at the end, and everything else. So we're going to chug along at a decent speed. We've got a lot to cover. At the bottom of the stack is, of course, the database. In this case, we're going to be using SQLite, and we're going to be using SQLite in memory rather than on disk, mostly because when we start looking at performance, I'd really like to be benchmarking the actual web service that we're writing rather than the speed of SQLite on my tiny little MacBook Air. We'll be building a data model on top of that using the SQLx library, which will interact with the database, handle database migrations, storing the data, updating it, reading it, and so on. On top of that, we're going to put a REST API using Axum. Then on top of that, we'll throw together a quick JavaScript and HTML app to let you access and use the data that's in there. And because I'm not teaching front end, that's going to be partly pre-made. And finally, we'll wrap it up in a Docker service so that it's containerized, it's ready to go, it's ready for you to use. And then we'll have a quick look at performance and how this actually how this can help you in production with very, very little in the way of system resources. All right, so part one is going to be the database. Like I said, we're going to be using SQLite, and we're going to be using SQLite in memory. What it means by that is that every time the application starts, it makes a brand new database in RAM. So we have to run the migrations every time we start. The upside of this is that you have a nice, repeatable, very easy to demo setup. It's very fast. The downside, of course, is you're not actually persisting your data. So when you use this on a real system, you'd probably want to use a real database. We'll talk about that a little later. Okay, so setting up the project follows the pretty standard template that you create the project with cargo init, and in this case, in the repo, I'm using a project named Webinar Axum, and run the command line tool, cargo install SQLx CLI, and create a file named .env. And this represents the environment variables that you typically use to share secrets and configuration information between your deployed systems. .env is kind of a convention used across a lot of platforms. You put your environment variable declarations in it, and if the environment variable is not set, then these variables from this file get used instead. And lastly, you will use the command SQLx migration add, and we'll name it initial. And this will create an empty SQL file and tie it into the SQLx migration system. So let's pop over to the code. and have a look at that. So this is actually the completed project for the end of it. So we've got a little more here than we need to worry about right now. But the .env file is very straightforward. Database URL, where we're storing the database, how you connect to it. We're using SQLite, and memory colon is the standard format for specifying I want to have it in memory. All right, so when I ran the cargo migrate add, I created an empty SQL file. And in this case, I've just put in some SQL describing what it is that we want to put into the database when we first create it. So we create a table called books. We're setting up an ID number, which is an integer, primary key, and auto increment, which is SQLite's version of serial in other databases. It automatically keeps track of the last ID number issued, uses a new one, it's atomic, so you won't accidentally end up trying and insert two things with the same primary key. We're keeping this simple, and so I'm going to put a couple of rows into the database just so that we have something to work with when it gets started. So we insert into books, title, author, Hands on Rust by me, and Rust Brain Teasers by me. So nothing too revolutionary there. Very standard SQL. Now, one thing I have run into is that very standard SQL is less standard than you might like between platforms. So if you're targeting Postgres, if you're targeting MS SQL Server, SQL Server, MySQL, or anything like that, sometimes you'll find that this isn't quite as standard as you might want it to be. So it's a good idea to make sure you're testing on the platform that you intend to actually use. All right, so that was enough to specify what the database will look like. And we're going to have the code actually drive the creation of the database, the creation of the schema, and all of these steps necessary to use it. And so the first thing we have to do is add some dependencies. I've actually added these ahead of time, and my cargo TOML looks like this. So we have package, or named Axum CRUD, like I said before. We're using Takio. Takio is the base layer. It's the async runtime. We're using features full, which means it'll have all of its features installed. If binary size is an issue, you can start trimming this down. Just to simplify error handling a little bit, I'm using anyhow. A lot of the time, if you take Rust Foundations, you'll find out that I like to start with anyhow and then use this error to start building specific errors. .env is the crate that supports the .env file that we created. CRD, I apologize, on previous presentations I've been calling it CRD. I ran into some people who worked on it, and they tell me that I should say CRD from now on, so I will, short for serialize, deserialize. Again, another big topic from the classes, but it is a nice format agnostic serialization, deserialization layer. SQLx, which we are currently using version 0.7. When you set up SQLx, you always have to specify the databases you want to be supporting, and what runtime you want to use. So using runtime Takio applies a few optimizations that help it work with Takio, and in this case, we're using SQLite. We're using Axum. Axum is a database. We're going to look at that in a little bit. We're using once cell. An awful lot of projects use once cell. We won't touch it till the end. It's on its way into the standard library. And we have a dev dependency, which is a dependency that only gets compiled when you're running tests or benchmarks, which is the Axum test helper. We'll see how to use that in a little bit, but that is a nice, convenient way to write unit tests that work with your web service. All right, so with all of that in mind, we can go ahead and start working on our main file. And it's actually pretty simple. We're going to put moddb because we're going to write the database logic in a file called db.rs that includes it into the project. We'll make sure it compiles, gets used. We're going to use a function from that crate we're going to write called initdb, which, funnily enough, will initialize the database. We'll be looking at that in just a second. We're going to use anyhow result, and one of my favorite patterns is to have main return return an anyhow result. So whatever error happens to bubble up to the top, if something goes wrong during actually starting the application, the error message bubbles all the way out into the stack trace onto your console, gives you immediate feedback that nope, this isn't going to work. And so first thing we have to do once we start the main is .env.ok, which loads the .env file, applies any environment variables that it finds there, sets them up, gets it going. And then we use initdb to initialize the connection pool. So let's go ahead and start writing that. So we create a new file called db.rs and put it in our source folder. And let's pop over to the source, and this is pretty much the completed version, but we're going to make a structure that represents our book, just like it mirrors the SQL. So you have an ID number, the primary key, integers from SQLite are I32s in Rust, 32-bit integers, title, and a string. And we're deriving debug so that if we need to, we can print out a debug print of what we're doing. Serialize and deserialize, which is SERDI, allows it to convert it between formats pretty easily. And from SQLx, we're implementing from row, which is just a helper function that allows you to write a select query and have a select directly into the structure instead of having to write a bunch of, get field 0, get field 1, get field 2. It's a helper. It just shortens the amount of code we have to write. All right, so the next thing to do is we're going to create the connection pool. Connection pools are a very, very important thing to have in your application and make sure that you get right. If you have a connection pool that's appropriately sized for your database, you can ensure that you don't overload your database. You can ensure that whenever a query needs to happen, it won't spend a lot of time making the connection authenticating. The connection's already there, reuse. Very, very important to high performance computing and built right into SQLx as a core concept. So let's have a look at how we do this. We set the database URL. stdenv var is the quick and easy way to return a value from attached to that key from the environment variable list. Database URL. And the question mark there says if we don't find a database URL, bail out, because that's a fatal error. Connecting and creating the pool is pretty easy. SQLite pool connect, give it the database URL, and we're in async land, so you await it. And what this does is it gives the database, the actual database layer SQLx time to talk to SQLite, make sure the pool is actually up, return back, and once again, question mark, bail out if we can't create the database pool, because that's bad. SQLx has migrations built right in. So if you have the SQLx CLI command, migrate command, migrate directory set up, then using SQLx migrate macro with the exclamation mark, .run, and give it a reference to the connection pool, will run whatever is in your migrate folder. And if you're on a persistent database, it actually creates a migrations table, tracks where you are, makes sure migrations don't get run twice. In this case, we're in memory, so we want the migration to run every time. And so with that said, we say nothing went wrong, okay, and we return the connection pool that we're creating. Okay, so now that we've got a database, and when it starts up, it's going to get the structure, it's going to get the database rows, we can start filling out functions that actually retrieve data from it. From row, which we added to the book structure, is a really, really helpful function, but it's worth noting this is not an ORM, an object relational mapper. It's not like the days of Hibernate. You can't retrieve your structure in a variable, change something, and then magically update the database. It's a helper. It just takes the data, matches by column name matching field name, populates the structure. But it lets you make the read part of CRUD very, very straightforward. So you create a public async function called all books. It will receive a connection pool. So Connection pool is designed for you to either send by reference or clone around. It's got an arc behind the scenes. It's designed to be easy to spread it around. And because it's an arc behind the scenes, you can be sure that there's only one connection pool and you're not going to accidentally make another 50 connections to your database in different parts of your program. And we're going to return a vector of books, which we're wrapping in a result so we have a chance to record if something went wrong. And the SQL itself is very simple. Select star from books, and we're going to search by title and author. So SQLx namespace query as function. The only strange thing here is what's called the turbofish, which is the two greater than less than angle brackets. You specify two types. We're using underscore, the placeholder, for I don't really know what type goes here, figure it out, and Rust will. In this case, the first type is actually the representation of the type coming from the database. We don't need to know that, but we do need to specify the second one because we want to receive our result in the format book, which is the structure we created. So that's easy enough. We call fetch all, which executes the whole thing, does the mapping to each of the structures, populates that into a vector. We await, give the database a chance to run, bail out if any errors occurred. Boom, you've got all the lists. You've got a list of all of the books sorted. Likewise, book by ID is the same thing, except we take an ID number. We use SQLx's bind syntax for $1 and then bind ID. Those line up, and that prevents any sort of SQL injection happening. We fetch one record, and we await it. We send it back. And so, depending on how you're counting, that's either one line of code inside the function or four, because technically each of those dots in another one is still part of the same line of code, but very, very short, very sweet, to the point, very simple. Creating records is also very straightforward because SQLx maps beautifully. Like I said, it's not an object relational mapper. It won't map that from row structure we created for us. We have to actually write the insert query ourselves. If you dislike doing that as much as I do, then paste your database schema into ChatGPT and ask it to create an insert query with placeholders. It'll do it beautifully. Otherwise, you can just write it by hand. In this case, it's simple enough. I just did that. And so function addBook takes a connection pool, takes a title and an author. We're generalizing using the generic toString. Talk about that a lot in the class. But basically, you can pass in anything that can be converted to a string. This just prevents your user from having to remember to type .toString at the end if they type a literal. And so we convert the title and the author, and then once again, SQLx query. We're not specializing the type here. Insert into books, title, author, values, a couple of placeholders, and returning ID, which will give us the newly created primary key ID. So we bind the title, we bind the author, that fills out the placeholders. We fetch one because we're going to have one result telling us what the ID number was. We wait for the database. And .get is the other way to extract data from a query. We could have done from row and created a special structure just to get the ID number. I thought that was overkill, so I'm just going to get the one field that's being returned, and we wrap that in OK, return it out. Again, very straightforward. Updating and deleting records. You really should have figured this out by now, because once again, we just use data binding to connect the data to the query we're creating. So updating, we take a connection pool and the book we're going to update. We set the title and the author to whatever's in that book object, and we update where the ID equals what the book's ID number currently is. And because we're not returning anything, we don't have to fetch, we just call .execute. Deleting a book is even simpler. You just take a connection pool and ID number, SQLx query, delete from books, where ID equals your placeholder, which is the book's ID number, execute it. Oh wait, and because we've got the question mark there, it will pass the error out of your function every time an error occurs, and make sure that, so that way you can track your errors, make sure that everything worked, and you'll be good to go. And so those functions give us CRUD, create, read, update, delete, on the database level. But seeing is believing. So I wanted to make sure that we unit tested every single one of them. I actually wrote the unit tests and ran them before I wrote anything else in this program, just to make absolutely sure that this layer worked. That is a great pattern. And SQLx and Takio between them provide a bunch of helpers that make it pretty straightforward to write unit tests. And Rust, of course, has unit testing built right in at the base, integrated with cargo test. Everything's all set for you. So we do the usual config test mod test. What that does is it ensures that your unit tests won't be in a build that isn't running in test mode. Using superstar means we give ourselves access to all the functions that we've created in the parent namespace, so all of our CRUD functions. And as each test runs, because the order tests run in isn't entirely determinate, and they frequently run multiple tests at once, we'll run .env just to make sure that we have the environment variables in the test that we're running. Initialize the database in memory. In this case, we retrieve all rows and assert that it isn't empty. We could assert that it has 2 entries, but other tests may be modifying the database at the same time. We don't really want that to happen. Likewise, test 1, same pattern, read environment variables, initialize the database, call book by ID, make sure that entry 1 is hands-on Rust, which, because the migrations ran, it really should be. Likewise, we test creation by creating a book, retrieving it, and making sure that it's what we said it was going to be. We test updating by loading book 2, changing the title to updated book, update the book. Once again, we retrieve the book, make sure the title's the same. Delete a book by adding one, make sure that it's there. Then we delete the book, retrieve a list of all the books, and assert that the new book isn't in the list. So again, very simple, including all unit tests and a caching layer that will be added at the end. We're at a couple of hundred lines of code. The actual CRUD part, though, is absolutely tiny. The tests significantly outweigh the actual program, which is often a good sign for a well-tested program. Okay, so we've got ourselves a database, we've got a data layer. Now let's fire up Axum and create a REST API to consume it. So Axum is very similar to Express on Node.js in the sense that when you fire it up, you specify a router or router, depending on which country you're in. And that router maps between URL routes and functions and the verb that activates them. So in this case, we want the root of our router to fire get all, fire the verb when for a get request, the verb, we call get all books, which we'll write in a moment. Likewise, if for a get book, which will just be one book, you go to slash and then an ID number, and we represent that as :ID. You'll have a look at how that works in a moment. Axum makes a lot of this very, very straightforward. It's very easy to read. You can see that /add goes to a post method to update a book. /edit puts an update to the book. /delete with an ID number deletes a book. So it's a relatively straightforward mapping. I've created a file called rest.rs that exposes all of this. And so a function called book service, and it's often handy to have a function for each service that you're going to be exposing that returns that, because then the master can map where you want it to go. Pretty straightforward. So over in main, we're going to, we want to make sure that, first of all, the web server knows what it's serving. And we also want to make sure that the web server listens to the network and actually handles traffic coming in. And so we create a new function called router. And the reason I'm putting this in a function and not in the main function is that I also want to be able to access this from unit tests without running the whole main function every time. And so this also returns a router. This is where it gets a little more complicated. In this one, we make a new router, and then we use nest service. with the books service. And what nest service does is it allows you to specify the parent on the URL chain, so in this case, /books, and then attach all of the services that are returned by the function it calls below that. And so where we put slash for get all books, it's actually going to be /books. And this is really, really nice when you're building a big complicated service and you want to logically express a bunch of different services. Keep your concerns separated in your code, spread everything out nicely. And so in the main function, we still got .env, getting our environment variables set up. We still build the connection pool. We call the router to make the app. And you'll notice the one last thing we're doing here is that we call .layer, which adds a dependency injection layer to our Axum service. In this case, we're putting the connection pool into the web server, and now any web server function that gets called that includes that in its parameters will automatically get the connection pool. And so we don't have to worry about trying to make a static, share it, or any of that. Axum does it for us, actually using a service under the hood called Tower. Tower is a very, very powerful system. It in turn utilizes Hyper. Takio is part of Takio underneath that, and this is all written by the Takio team. Axum, as a result, utilizes this and offers a pretty nice, clean API. Okay, so now that we know where to map things and offer the connection pool as a service, we set our listen address, which in this case, I'm listening on any IP address, port 3001. So we bind the Axum server bind to that address. We call .serve, and our router type implements a function called make into service, which turns it into a Tower service. Off it goes. It's running. We're awaiting it. It's not actually going to return unless the web server dies completely. So at this point, the program will just sit at that point being a server. If you wanted to launch other things, you can use Takio Spawn there. All right, so actually retrieving the books via the database level is once again very straightforward because the Axum system is extremely ergonomic. I remember when I started using it, I thought, yeah, it's a little verbose, but this is really powerful. So we create an async function called getAllBooks, and if you remember, we listed that already in the router. First parameter uses the slightly strange syntax here that the variable is named extension, and then in parentheses what I want to call it, and out of habit, connections frequently get called CNN in my code. That's probably not as good as it could be. And the type is extension, which is actually Axum extension. And then in angle brackets is specialized to be the SQLite pool. Now that type matches exactly what we inserted when we set up the initial router. And so when Axum executes getAllBooks, it will populate that CNN for us. You don't have to do any magic whatsoever. You've got a connection layer. It's all good. And so now we call all books that we created from the database layer. And if let OK, so if it gives us a valid result, we can just OK, call the Axum type JSON, which will automatically, because we wrapped our book type in serialize, convert the whole thing into JSON, build a valid response, boom, it's on its way. You've got a vector of all books. Otherwise, we're going to return an error service unavailable. That's why our function is returning a result type, where the error is status code and the good path is JSON vector book. Getting a single book is almost exactly the same thing. Get book, dependency inject the database connection pool. Path ID, once again, if you remember in our list of services, we put :ID. Well, that matches for the variable ID. Axum will fill it in for us. We don't have to do any magic to get the path variable. And so we can just call book by ID from the database model we wrote and await on it, return the book. And this should start to look pretty familiar. Add a book. Again, we get the database layer. This time we're using Axum extract JSON because we want the body of the post that arrives with a book in it to be converted into a strongly typed book variable called book. And Axum will again take care of all of that for you. And so we call add book, give it the title and the author from the book that was posted in, and return the new ID. Again, very little code. And the update part, this is exactly the same. We get the book, we call update with the book, off it goes. So in 86 lines of code, including white space, you have a complete CRUD. Axum system that calls our SQLite code and gives us a nice, gives us a really nice, easy interface. You can write CRUD APIs all day like this. I don't recommend it, but you can. So of course, I want to unit test all of my CRUD functions, make sure that the API actually works before I start telling people, run your program, connect to it, all is well. And so we're going to make use of the Axum test helper crate, which exposes a handy little type called test client, which is actually used internally throughout Axum. And for whatever reason, they didn't expose it publicly in their API, and the test client crate just gives it to you. Our unit tests, once again, only compile in test mode, make a module called test, import the functions up above, import the test client, and we made a helper called setup tests, which will return a test client, which initializes to make sure the database is available. We call our router function from the top level to build the Axum router. And then we can initialize a test client, which allows us to very easily make calls into our API and make sure that it matches what we expect. And so unit testing the REST framework itself is then pretty easy. Using Takio test, which is a macro to quickly and easily get you asynchronous tests, we're going to run a test called getAllBooks. We use the setup tests function we wrote on the previous slide, and we call client.get, and so client, we issue a get request. That's the verb, the HTTP verb. The path is /books. We send it. We await a result. We're going to assert that it returned a status code OK, which is status 200. We call res.json, which automatically takes the result and serializes it for us into a vector of books, and we assert that there are some books in there. And when you go through the code, you'll see that we have get all books, get one book, add a book, which follows the same pattern of adding a book and then making sure that it's there, update book, which gets a book, updates the book, makes sure the updates are there, deletes the book, exactly the same pattern we used before, but it makes sure that all of our API endpoints are fully covered in unit tests, and you have a working system that you can just run cargo test. I'm in Rust Rover here. I probably should have used the Rust Rover UI, which is what it's complaining about, but I kind of like the actual output. Running 10 tests, every test worked. So we can be pretty sure before we start exposing this to real-world use that our database layer works and our API layer works. So that brings us on to building a web view. That is, proof of the pudding is in eating it. So let's go ahead and do that. I added a new file called view.rs and a line mod view to the main file just to load it in. Let's have a look at what this looks like. It's apparently decided to compress everything. There we go. And so we've added a view service, which just makes a route with a single entry for the / the top of the site that calls index page. In this case, I've just used include string, which bakes a file into your executable, and that's their tower offers a whole bunch of useful helpers like serve dir and serve file for handling serving with caching. In this case, I just wanted to keep it simple. I'm just returning HTML, which is an Axum response type, containing my index page. Now, the index page, like I said, I'm not here to teach HTML, but we retrieve Bootstrap, which I'm using for layout, jQuery, create a little web form, and some JavaScript functions. You're welcome to have a look at these in the live, in the code running live. Sorry, in the code on the repo. So run the program. Yes, I am going to allow it to listen. And there we go. We have all of the books we created. Click on one, gives you the option of making changes. We can delete. And so there you go. In relatively little code, you've got a working REST API, including a web framework to use it. All right, so the last thing I promised we'd do is containerize in Docker. And this was actually extremely straightforward. So I'm not going to demo it, not going to demo this live, but I'm just going to make sure that you know how to do this if you need to. I literally ran Docker init. It asked what language I wanted to use. I said Rust. It asked what port I was exposing and suggested 3001, which was kind of handy because I was right. So I selected 3001. And then the only two changes I made were to stop me having to remember to put the database URL in as an environment variable. I actually added it into the Docker file. You don't need to do this. In fact, in production, you probably shouldn't. And I added one line to the automatically generated binds. I added mount type bind source migrations just to ensure that the two-stage compile also has the migrations folder when it gets there, because what Docker does is it builds the first stage with the official Rust builder Docker system, which is a Debian Slim with everything you need to compile Rust, builds the program, and then it pulls the result artifacts out and uses that to build a pretty small 80 meg Docker file containing our application. You can get smaller than that. I didn't spend a lot of time trying to optimize it. I was just happy to see that it worked. So then you go into Docker, you build your container, start it up, go to localhost 3001, up comes the UI. You have a working Docker system, and because you use Docker init, you've got the beginning of everything you need to start deploying out to a Docker swarm, or with a bit more configuration, Kubernetes if you want to. All right, so far so good. We have a nice, shiny, working CRUD system built from the ground up, and you'll notice that we are 41 minutes into the stream, and so in 40 minutes, I was able to show you all of the functions that are there. It actually took me just under an hour to write the whole thing from scratch on my little MacBook. Easy to do. Rust is pretty ergonomic for this. It really doesn't get in your way. There are crates that can automate some of this, but I wanted to teach the principles, make sure you understand what's going on before you start diving into the way that into ways to make it even quicker. So we've got ourselves a database layer, we've got a database model, we've got a REST API, we've got an HTML JavaScript view of it. So how resource intensive is this? And when it's mostly idle with just a few requests, mostly me clicking on it, adding, removing books and similar, Docker claims that we are using a whopping 1.95 megabytes of RAM. And that I didn't believe that, so I pulled this up on a couple of Linux boxes and checked. And there's a very short burst at the beginning, but overall it's using almost no memory because the in-memory database is absolutely tiny. Tokio and Axum are both very slimline and really won't start using resources until you start hitting it with requests. And so for a lightly used service, you can probably stop here, no more optimization. We're hardly using any RAM. You could have thousands of these if you wanted to. On a production server, you could probably even have hundreds on the little MacBook Air that I tested and deployed this on. So I pulled up a handy little load testing tool and fired 500 requests a second at it just to have a look and see how this is going to scale. Once again, I'm on my little MacBook Air, so put this on a real server and you should start to see much, much more impressive results. But I managed to peak at 12% CPU usage, which isn't too bad considering I haven't optimized anything. The absolute worst result latency-wise was at the very beginning, and that's because a lot of initialization in Axum is lazy. It doesn't initialize everything until you start looking at it, and so the first couple of requests were pretty slow, and by slow I mean about one microsecond. So really not very slow at all, well within the 5 microseconds that you need to aim for most of the time before people start to notice. But the 50% percentile 240 microseconds, that's really good. And if your 95th percentile is only 399 microseconds, that's not a lot of variation. Your services are running really quickly, so at 500 requests per second, I'm going to say that this service is ready. You can deploy it on a MacBook Air, but you'd probably want to actually get a real computer that doesn't power off if I forget to plug in the USB, and it's good to go. So I hit it with 5,000 requests a second, which turned out to kind of break the test tool I was using. But absolutely hammering it with that, my little MacBook Air is starting to struggle a little bit, not too surprising. I'm hitting the get all books API endpoint. So every single one of these requests is performing a full table scan, retrieving the whole thing, deserializing it, putting it into a vector, and sending that to the client. So that's kind of an inefficient, heavy thing to be doing. You probably wouldn't normally want to do that 5,000 times a second. But it doesn't matter because guess what? It didn't crash. I started sending out hundreds of megs of network traffic, processed 213,000 requests, every single one of them, status code 200, no errors whatsoever. So the latencies remain really good. While it peaks at a worst case of 9 milliseconds, that's not so good. The P50, the normal, 50% of the time, 192 microseconds, that's great. P90, 315, P95, 539. So we really only in that 1%, which was pretty much during ramp up at the beginning, started to see some latency issues. The rest of the time, we're getting very, very good throughput on a tiny little MacBook. And so I said to myself, I'm demoing this lot. I'm going. There were 3 rows while that was filled for Expo. So that's very small database because I'm mostly trying to benchmark the system itself more than the database layer because SQLite is pretty slow. But I also wanted to give you sort of a baseline that Rust is really fast. On the LibreQOS project, we deploying to some pretty beefy servers for our stat service. We typically see latencies under load in the 150 to 200 microseconds, and that includes hitting timescale for enormous queries. So this scales, it's good. You don't have a lot to worry about. But Rust offers a promise of fearless concurrency, and so I wanted to make a concurrent cache. I'm pretty sure this is going to be a little too small to read, so I'll switch over to the code view real quick. This is not a good cache. This is a cache that I could write in 10 minutes. And so I create a structure, book cache. I create a container field, all books, wrap it in a read-write lock. That is like a mutex, but but you can have as many readers as you want and only one writer. Writer has to wait for all the readers to go away, and then nobody can read it until it's done writing. It's a Very handy structure. Inside that, we put an option, so there may or may not be a cache list of books with a vector of books. When we first initialize it, we'll create a new read-write lock with no data. And then we just add a simple getter for get all books, which acquires a read lock and returns a copy of the vector. You could probably do this without a copy. I wasn't pushing for super performance here. I was pushing for easy to demonstrate. Refresh takes a list of books, obtains a write lock, replaces the contents of the cache with that list of books, and because of the drop trait, the lock will be released as soon as the function exits. And invalidating the cache simply empties it. And so we modified the retrieve all books to if let. So if the cache of all books contains some data, we'll just return from the cache. If it doesn't, then we'll run the query, dump that into the cache, and return books. Hold on, I'll get to that in a moment. Okay, so then the only other thing I did there is I threw in cache invalidation calls on update, on delete, to make sure that if the cache changes, then it'll have to be rebuilt. And so now on my MacBook Air, 5,000 requests a second doesn't even break a sweat. So I've stopped doing the stupid thing of hammer my database for every single request, because in this case, there's really no need. We're not adding, deleting, updating books all that often. And this is a really common pattern most of the time. Writes and updates are far less common than listing what's there. That may not match your traffic pattern, but in this case, it makes a certain amount of sense. And so I stopped this one a little earlier, 116,000. My CPU never got above 22% during the test, and that's 2 Docker instances talking to one another on my little Mac Mini. Oh no, my memory usage actually grew to almost 5 megabytes at one point. I think I can handle that. 22% CPU, not pushing huge amounts of data, but once again, this is a demo. It's not trying to push something live into production. Okay, the question I saw was, how did I get the R Rust icon on the right strip of the IDE? And the answer there is I'm using Rust Rover. It's available free from JetBrains while it's in basically alpha. It will flash up with errors quite a lot, but it is a nice, pleasant environment to use. I recommend giving it a go. They put those icons in. I haven't customized anything because I've really only had this since RustConf. All right, so feeling. I'll answer that in just a second. So how about 20,000 requests per second? Once again, it's still going. My CPU is starting to thrash a little bit, up at 73%, but we have no errors. So I can be pretty confident that this service model is going to scale nicely in production. I'll answer that tool question as soon as I can find the right window. 1 second. I was using a tool written in Go called Ali, A-L-I. I don't know if I'm probably going to regret trying to run this live, but so if I disappear, it was a bad idea. Yeah, here we go. ALI, it's an open source free tool. It's not the best load generator in the world. There are far better tools, but for quickly testing something, it does a great job. We'll display percentile charts and similar. I'm running the whole thing in debug mode right now, which is why it's going a little more slowly, but it's a great tool to keep in your tool belt, and one that you'll find will serve you well for quick and dirty. I want to make sure that my web service is going to at least kind of scale to whatever sort of level of load that I know I need, because most of the time you don't really need 20,000 requests a second. Okay, so That brings us towards the end. What have we learned? SQLx provides a lean and mean expressive database layer with migrations. There's a test fixture system. I'll answer Daniel's question in a moment towards the end. Axum provides an expressive enterprise-ready foundation for web services. Rust integrates great with Docker and containerized builds. And Rust glues everything nicely together, giving you small and really fast and relatively easy to put together uh, REST APIs. And it's because Rust is so great with concurrency, it's easy to start adding things like caches and not worry about accidentally corrupting your data through a database, because Rust simply won't let you compile it if you have one. So in my opinion, Rust is a great choice for line of business REST apps where you don't have an existing framework that you want to utilize, or you need something really small or really high performance to fill in the gaps. And so because I'm only here for an hour, there's always improvements that can be made. Here's a few things that you could add to this, and most of this is already in the Ultimate REST Foundations class that I teach, that we'll be talking about momentarily. But adding in tracing through Takeo tracing, you can easily log requests, you can easily log individual events, and you can attach span timers to start giving you exact timings for different parts of your program, how fast they ran, how much time they spent waiting in async land versus actually doing something. This in turn links into OpenTelemetry very, very easily. You can, with just a couple of lines of code and some configuration, have your events spinning off into your OpenTelemetry setup and start looking at them, graphing them in your preferred setup. Obviously, in a real setup, I do not recommend using SQLx in memory mode. SQLx out of the box supports MySQL, PostgreSQL, and I believe MS SQL, although there's been some questions there. There are also native Rust drivers that follow pretty much the same pattern available for most databases out there. If you're going to be doing this in heavy production, you probably want to use a proper cache layer. You probably want to start looking at templating tools for your HTML and hire a graphic designer to make it look good for you. And so there's plenty more that you can do, but this should get you a ways into understanding the system and becoming productive pretty fast. All right, if we want to move on to the QA. Okay, Daniel asked, do I have a recommended crate for command line parsing? Yes, I do. It's called CLAP, C-L-A-P. And there's two ways to use it. You can specify with some macros and a declarative system. And there's a whole section in the class we teach on how to do this, which lets you pretty easily specify all the ways that your program can be invoked. It does a fantastic job of automatically deriving some of the help text from your Rust doc comments. It automatically gives you a minus help, lots of flexibility and functionality. You can also use builder pattern to describe what you want if you prefer that to decorating with macros, but clap is excellent. I didn't see any. Were there any other questions that I missed? I think we're okay there. All right. With Arden Labs, I spent a delightful week down in Miami recording the Ultimate Rust bundle, more than 20 hours of content in total. We used to teach this live directly, probably still will again, but it's 5 4-hour sessions in taking you pretty much from zero to hero. You start with Hello World. By the end of the first day, you're writing a full command line application using clap. By the end of the second day, you're making threads, scheduling your threads, understanding protecting your data with mutexes and similar. End of the third day, you're into async, building high performance, very Go-like green thread type setups. Then there's some theory, making sure that the borrow checker, memory model, ownership, and similar are things that you understand, and you understand why they're there to help you and not to make you miserable. The final day is actually a capstone project where you build a tiny little data collector that sends data over a really tight TCP protocol to an ingester, stores it into a database, build on top of that a REST API, and a display system with pretty graphs and all kinds of things. So the Ultimate REST bundle is everything you need to really get started with beginner REST, build good REST programs that can be useful almost immediately. And I had a ton of fun recording it. Dragon Max asks, will there be a class for Beyond Foundation, sort of next steps? And the answer is, I very much hope so. I've started the discussions on that. One of the classes that I would like to teach is actually a similar to the Go service concept, where describe everything that you need to go from start to finish with building a deployable, usable REST service template you need. Some of that's in this class. That's why I went ahead and did this, and also to advertise the bundle. And so we'll hopefully have some announcements on that coming soon. I don't know a time frame. All right, that's the Ultimate REST bundle. We're also doing hybrid training, which is the same thing, that you have the videos, but in addition, you get weekly QA sessions with me, as well as a kickoff, in which I will gladly talk to you about what you ran into, how you progress through the class, help you out. So it's more of an interact with the instructor model, but at the same time, you've got self-paced learning that should fit into everybody's busy modern schedule. All right, I think we are on to the prize draw. Okay, Eric, spin the wheel. And the winner of this should receive a Ultimate REST bundle. Wow, I forgot it made that sound. Okay, I hope I'm not mangling the pronunciation. Akanksha Nitrale. Are you in the chat, Akanshka? If you are, say something and we'll send that off to you. The bundle, Dragon Max asks, is the bundle available now? And the answer is yes. And there's one of the hybrid sessions is starting very soon. I believe there's still space in there. And so if you prefer just the bundle, that's available right now. If you prefer the hybrid, I believe the next one, sorry, is coming right up. Okay, I did not hear from Akanchka, so I guess we spin again. All right, is Lucio Moraes. I hope I said that even vaguely right here. Otherwise, we may be spinning this for a while. Okay. Yep, I will. There's a couple of wonderful people from Arden helping me run this, and so they're clicking spin the wheel, and I'm really just being the not so pretty presenter right now. So, Valentian P. Um, yeah, and I also can't see the list of who's in the chat right now, so hopefully, if you are there, just say something and we'll get this sent off to you. Oh, there we go. All right. I think Eric and Casey. Was that one of the names we just called out? I'll let them take care of that. In the meantime, I just wanted to thank everybody for coming. I enjoyed teaching this. I hope it was a good introduction. And I hope I will see you in one of the hybrid sessions, or if not, at one of the conventions that we'll be visiting soon. Thank you so much.